History of C. C was developed by Denis, Ritchie and Kernighan in 1972 at Bell Laboratories. Initially, Denis, Ritchie and Kernighan renamed this new programming language as K and R C. Later on, American National Standard Institute (ANSI) standardized this new programming language, which was introduced by both these scientists and renamed it as ANSI. C was originally used to create Unix operating system, but later on it also became a foundation for system programming. C has inspired many object-oriented programming languages, and they have been evolved from C, like C++, Java, Python. It remains widely used for C+ system programming, embedded systems, and developing operating systems. Features of C. C is considered a simple yet a powerful language, where the features of C are considered very simple for a programmer to understand and learn, and user can create simple as well as complex programs. Structured language is provided in C because it supports all the important functions and blocks in an organized manner, and it also supports modular programming feature, where you can keep on adding multiple modules in your existing program and expand the program extensibility. Portability feature enables the C program to execute on different systems with very minimum modifications. C also supports low-level manipulation, where we as a programmer get direct access to memory and hardware to work and understand how the memory is managed to handle data. C also provides rich library like handling built-in I/O functions, data management, file handling, and much more. C provides efficient execution for C programs, like they are fast and it is suitable for performance-intensive tasks. So with this multiple features available in C, it is always considered as one of the basic programming languages to learn before jumping to any other object-oriented programming language. Let us understand some important fundamentals of C programming. Tokens and identifiers. Tokens are nothing but the smallest unit of the program, like keywords, identifiers, constants, strings, operators, symbols. These are the smallest tokens, and in these tokens you can create expressions and then executable statement. Let us take an example. C equals to 1 plus 1. So in this case, C, 1, 1, these are the individual tokens, is equal to plus, these are also individual tokens but in form of operators and symbols. So using these individual tokens combined together in an expression, you can create an executable statement. Identifiers. Names given to variables, functions, and other user-defined entities that are created by the user for the current program scope only are called as identifiers. So we can create variables to store values, functions that can be called from any other function, and you can also create arrays, structures as needed in the program. These variables and functions which are created for the program are limited with the scope of current program usage only. So whenever we create identifiers, we must keep some rules in mind, like identifiers must begin with a letter or underscore. No special symbols are allowed here, like no special characters are allowed, no spaces are allowed, and they are case sensitive. We must keep identifiers readable, so we can have a meaningful readable small words to understand what these identifiers or variables are going to store in it. Let us have an example of few valid and invalid identifiers available in C. If we say num1, it is valid as it is alphanumeric and begins with a letter. And if we say $1, so it is invalid because it uses a special symbol in between. If I say underscore N1, it is valid because it is beginning with an underscore, as underscore is allowed. And if I say 1N, it is not allowed because it is beginning with a number which is invalid pattern of writing an identifier. Let's move ahead. Keywords. Keywords are the reserved words. They are holding special meaning in C. We must keep in mind keywords cannot be used as identifiers like as users, objects or users, variable names or function names in your program, because they are already holding some special meaning as defined by Denis, Ritchie and Kernighan in their library. There are total 32 keywords available in standard C library files. So few of them are say int, float, return, if, else, etc. Whenever a particular keyword is encountered in the program, the compiler understands the main important task to be performed in the background so that the program works as expected for the programmer. We will learn about keywords further as in how we move ahead with the course of C programming. Let us understand data types and their categories. First of all, why do we need data types? We need data to store values, but also compiler needs to understand what type of data is getting stored or handled or managed. So, the term says data types help the compiler to understand on what type of data it has to work, how the memory must be managed, and how the data must be stored in particular data type. Primarily, C supports three basic data types like integer, float, and character. Integer says that I can store only whole numbers like 1000. Float and double say I can store decimal values like 3.14, the numbers which are having fractional parts also. And character says I'll be able to store single characters, let's say in single quotes I. So I'm storing a single letter I. Whenever we create a variable of any of this primitive data type, we need to mention the specific keyword so that the compiler understands that the variable is related to which type of a data type. For integers, we have to use int as a keyword. For floating point variables, we have to keep float as variable. For double type of variable, we have to keep double. For character storage, we have to say char. Let us take very basic examples here. Int I equals to 10. So this is an integer variable I who is holding the value 10. If I say float, I can say float pi equals to 3.14. It is storing a pi value of 3.14 in the floating point variable pi. Similarly, if I use double, I will say double D1 equals to say some number point decimal values of it. And if I want to create a character type of variable, I will use char as a keyword. Name of the character variable say A equals to and a single letter to store in it say I. So it is going to store a character I in the variable A. So these are primitive data types supported by C. Derived data types. Derived data types are used when we want to work on the similar type of a data type or mixed data types all together to make our work more simpler to solve complex problems. Some of the derived data types supported by C are arrays, which works on the similar type of a data type only, pointers, where it holds the memory address of some other variable only, structure, where you can use different type of data types all together in one variable itself, union, where you can again use different type of data type but in same memory location, and enumeration, where you can have named integer constants in a given list. We will understand each and every derived data types in the further course as and how we proceed further. So as we know, the basic data types are used to create variables Let us understand what range of value it can store and how much of the memory is needed to store in bytes. So int, as we all know, int will be able to store whole numbers, will be able to store values in two range like -32768 to +32767, which will need a 2 bytes of memory to store. However, if we go with a larger range, we can also use int to store the longer value, and it will need 4 bytes of memory. So if we want to create a normal integer, we can say short int I equals to 1000. So here it is going to store value 1000 as it is in the short range. But if I want to create an integer with a longer range value, then in that case I will have to use keyword long int I equals to your longer value. So whatever value you are going to put into this, it will be stored in the form of long int. No matter if you store even a single digit number, it is going to take 4 bytes of memory to store. Moving ahead, cal. Cal keyword is used to store a character in a character type of a variable. As you can see here, number of characters that can be stored would be -128 to +127 if it is signed, and 0 to 255 if it is unsigned. A character needs only 1 byte of memory to store one letter in the memory. Moving ahead, float. Float is a data type which can store decimal values. So as you can see here, the range is ±3.4 e -38 to ±3.4 e +38, which says a number between 3.4 into 10 power -38 to 3.4 e, which is like 10 power 38, and that range of number can be stored in 4 bytes of memory. Now double is an extended part of float where it can store same decimal type of numbers but with a larger range of numbers before and after the decimal parts. So here the range is ±1.7 e -308 to ±1.7 e +308, and it is going to take 8 bytes of memory to store in the memory location. And when we go with the long integer, apart from this previous one that we had seen, the long integer range totally depends on the platform that you are using, and it will need a memory of 4 or 8 bytes depending on the operating system supported. So moving ahead, variables and constants. Now as we know, data types are needed for a compiler to understand what type of data must be held by an identifier. We are now easily able to understand how we can create variables and how we can assign values to it. So first of all, what are variables? Variable is nothing but a named memory location, like a name given to a memory location where it will be able to store values as mentioned in the program. Now these values can be initialized at the time of declaration or may be altered during the execution of program. The value can be changed during program execution. So if we say an example, int age equals to 25, in memory block somewhere where it is having 2 bytes of memory free is given to age variable, and it is storing value 25 in it. Now this int is allowing a compiler to understand that it is going to need 2 bytes of memory and store whole number in the memory. Moving ahead, constants. Constants are nothing but fixed values provided to some variable, and we do not want to change the value of it throughout the program, which means that I don't want to change the value of my variable till the program is in the execution. So we can use const keyword in that case, or hash defined directive. We are going to see hash defined directives in further lectures. The const example is shown here, like const float phi equals to 3.14, Now here I don't want to change the value of pi at any point of time in my program, so I am preceding the statement with const keyword. So somewhere in memory again, it reserves the number of bytes needed for a floating point variable. Value 3.14 is given to it, and it is given, the pi is holding the address, and it is const, so that the value at this memory location will remain frozen as it is. It will not change till the program is under execution. So I hope variables and constants are clear for you. Moving ahead, syntax of declaring variables. So if we say a general syntax, first of all we have to specify the data type of what type of value you want to create. Moving ahead, syntax of declaring variables. With the general syntax, we have to first of all specify the data type to compiler to let it understand what type of variable we want to create and how much memory will be needed to store in the memory. Variable name rule applies as per the identifiers that we have seen previously, and value is optional part where you can give an initial value at the time of declaration or you can use it later on. So let us see an example. Int num equals to 10. So num is an integer type of a variable holding value 10. Float temp equals to 36.5. So temp is a floating point variable, as it is holding the fractional part of a number also, and it is needing this float keyword. And char letter A is the value of the letter variable and it is of the type character. So we must again revise what are the important rules of creating variables. As we see, the variable name must begin with a letter or underscore, and you must avoid using keywords as variable names. Moving ahead, let us understand what are main steps of executing .c to .exe program. So whenever we write a program in C, its extension is always .c. But when we execute the program, in fact, .exe is executed. Now .exe is generated after .c is converted and following few important steps. So first important step is, whenever we create a C program, we have to save it with .c extension. We compile our program and check whether there are any errors or not. After the GCC compiler finds that there are no errors in the given code, this C code is converted into machine code, which is also called as .obj file, like an object file. Now this object file is further given to linker. Linker is going to link all the important other library files and object files which are needed in the current program and convert into .exe file. Now finally this .exe file is getting executed and we see it on the output screen of our program. So I hope you understood how this .c is getting converted into .exe and why GCC and linkers are important to execute the C program. So let us have a brief look at a simple C program using a printf statement. I want to print a hello message or any of the text message on the screen. I will need a printf function. We will see this in this slide. The purpose of printf is just to display some text on console. So the syntax of printf says printf, all small letters, in parentheses. So this is a pair of parentheses. In double quotes, you specify the text which you want to print, then you give comma and variables if you are printing the value of variables. Let us see an example here. Hash include stdio.h. Now this stdio.h is said that I want to include standard input and output functionalities which are already written in this header file to this program. So this stdio.h header file is added in my program, so that I can use printf, scanf, different parts of functions and constants available in stdio.h in my current program. Now int main. Main is always an entry point for a compiler to start its execution, and the control is moved directly inside the main. The pair of curly brackets says that these are the content which I want to execute in main. Now within this curly brackets, whatever is written will be executed. Let us see what is it. Int num equals to 10. Again, integer variable is created of a num name and the value 10 is assigned to it. So somewhere in memory, it is going to hold 2 bytes of memory. Value 10 is assigned to it and it is pointing to num. Then I'm saying printf the value of num is %d, num. Now %d is a format specifier which is needed when you want to print the value of a variable. So for instance, if you are having an integer type of a variable, you will need the format specifier %d. If you have float, you will need a format specifier %s. If you have character like char, you will need format specifier %c. So here %d, because it is of an integer type, I am specifying it with %d. The value of num is replaced with this %d on the output screen and we will get the output as the value of num is 10. That's it. Then the statement written 0. Return is a keyword here. 0 is the value that I am returning. Now the 0 number says that there is a successful completion of my program and I am returning back to the IDE where the program was started to execute and compile. So this is how a normal C program gets executed when you are. So this is how a normal C program can be executed. So let us summarize what we have learned so far in this session. C has inspired many subsequent object-oriented programming languages like C++, Java and Python. Tokens are considered the smallest unit of programs, which includes keywords, identifiers, constants, strings, operators, symbols and so on. We shall learn them further in the next lecture. Keywords are words with predefined meaning, means they have special meaning and you cannot use them as identifiers. Identifiers can be created with alphanumeric or an underscore combination. Must begin with a letter. We have to understand the important rules to create identifiers. Primitive data types supported by C programming are integer, float, character and double. Variables can be created in specific data types like int, float, char, double. .c is always converted into .exe before execution. After compiler finds that there are no errors in .c, it converts it into .obj file. If it finds error, of course it will return you back on the IDE and ask you to fix up those bugs. And if the object file is created, later it is passed on to linker so that it can link to different library files which are needed to execute. And finally, exe file is generated for execution. Printf function is one of the most primitive and widely used printing functions to print the content or statement or text, expressions, results, etc. on the output screen. So I hope this was a wonderful session for you to understand the basics of C programming language. Thank you so much.